Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Probability and Statistics, Topic 5, Probability Generating Functions. Today's lesson is on expectation and variance. In the MF19, you're provided with the formulae for expectation and variance, which I'll post here. And this will be an application of probability generating functions. Once we take the probability distribution and get it into the form of a polynomial, our probability generating function, we can use the formulae for expectation and variance. Variable x, which follows a geometric distribution with a probability of 3 over 8. And here I'll apply the general form of the probability generating function for a geometric distribution, which we covered in the first lesson on probability generating functions. To get to the probability generating function for the variable x is 3t over 8 minus 5t. Note that's not given. Again, to review how to get to this probability generating function, you can check that out in the first topic lesson. Observe in the formulae we want to find the first and second derivatives of the probability generating function. Here we have a quotient, so I'm going to identify my numerator as my u function, my denominator as my v function, and then I'll work with the quotient rule to find g prime of x. The derivative of u, 3, times v, 8 minus 5t, minus u, 3t, times the derivative of v, which will be minus 5, all over v squared. 8 minus 5t squared. And simplify to 24 times 8 minus 5t to the power of negative 2, which gives me a format that I can easily work with for my second derivative. And for the second derivative, 24, I'll multiply by the exponent of the binomial, negative 2 times 8 minus 5t to the power of negative 3, times the derivative of the inner function, negative 5, and I can simplify to 240 times 8 minus 5t to the power of negative 3. Notice in our formulae we want outputs for the first and second derivatives using an input of 1. The first derivative with an input of 1. Looking at our first derivative, 24 times 8 minus 5 times 1 to the power of negative 2, which simplifies to 8 over 3. And the second derivative with an input of 1, 240 times 8 minus 5 times 1 to the power of negative 3, which simplifies to 80 over 9. And now expectation. Notice the formula is the result of an input of 1 into the first derivative that we have calculated as 8 over 3. And for variance, the formula is the second derivative with an input of 1. We have 80 over 9, plus the first derivative with an input of 1. We have 8 over 3. Minus the square of the first derivative with an input of 1. So minus the square of 8 over 3, which results in 40 over 9. Now let's look at a scenario in which we are given mean and variance, and we use those to find the probability distribution. So if I know that expectation of x is 2 over 3, and variance of x is 5 over 9, and I'm given an incomplete probability distribution for 0, 1, and 2, with probabilities of A, B, and C. I can use the expectation and variance to find these probabilities. I'll start with my probability generating function for x. And recalling from the first topic lesson, the procedure is that we take the probability, so starting with the first probability of A, and multiply that by t to the power of the relevant x. In this case, that would be t to the power of 0, so I can simply leave that off and I'm just working with A. Next, probability of B, the x of 1 gives me a t to the power of 1. And next, the probability of C with an x of 2 gives me t to the power of 2. I need my derivatives, first and second derivative of the probability generating function. So first derivative, the A will drop off because it's a constant. B times t will become B, and c times t squared will become 2ct. Then the second derivative, B will drop off because it's a constant in the first derivative, and we're left with 2c. We can further simplify because we're focusing on inputs of 1, so we can replace t with 1 in the first derivative. Input of 1 gives us b plus 2c times 1, which simplifies to b plus 2c. And in the second derivative, similarly, an input of 1, we simply remain with 2c. Notice in the second derivative there is no variable. So now let's see how we can use expectation and variance. Notice in the expectation formula, expectation is the first derivative of the probability generating function with an input of 1. We have that on the right as b plus 2c. That equals the given expectation of 2 over 3. For variance of x, using our formula, we want the second derivative of the probability generating function with an input of 1. Up above we have that as 2c, plus the first derivative with an input of 1, that we know is 2 over 3, minus the square of that same value, minus 2 over 3 squared. And we're given the variance. We know this equates to 5 over 9. Now let's work through and solve for A, B, and C. Starting with C here in the variance equation, notice that we have an equation in one variable. We can simplify to solve for C. C is 1 over 6. Then up at the top on the right we have B plus 2C equals 2 over 3. So that will become B plus 2 times the value we've just determined for C is 1 over 6 equals 2 over 3. And here we can solve for B as 1 over 3. And now we want to take the understanding that the sum of all probabilities, our three probabilities are A and B and C. A plus B plus C will always equal 1. So A plus the B we've solved for of 1 over 3 plus the C we've solved for of 1 over 6 equals 1. And we can solve to A equals 1/2. And now we have the three required probabilities. C, 1 over 6, B, 1 over 3, A, 1 over 2. And this completes the lesson on probability generating functions, expectation, and variance.